Good evening and thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He's passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will share my screen. Okay, so a big good evening to everyone. And let me walk you through the agenda for the day, and then we'll get started with it, right? Okay, so now if you have been joining me for last 2027 sessions, which we have done, you may have realized that we do very flashy all the sessions are pretty flashy. We work with Kubernetes, machine learning on Kubernetes, on Spark. Yesterday we were doing. The yesterday's session was on deep learning on distributed deep learning with Spark and Harvard on Azure Databricks. So today's session is a different one. This is more practical. You can say something which it doesn't matter which domain you work in, or it doesn't matter which type of algorithm do you use, any classical machine learning algorithm or any deep learning algorithm like what we were discussing yesterday. So it doesn't matter which type of algorithm you do or which domain you are from. This is something which fairness in the machine learning model or responsible machine learning or responsible AI is something which is absolutely required and absolutely important. And we do not realize how we may realize or may not realize that the impact of artificial intelligence in our day-to-day life as such, like the various decisions which the AI models take for you are pretty wide as such. So that is the topic for the day: detect and mitigate the unfairness in the models in machine learning, in Azure machine learning. The libraries which we will talk about are open source. You can use them anywhere. So now I just want to show you the learn module over here. So this is the link which you can follow after the session, and this is the link which is pasted in the chat window as well. You can go and bookmark that link, and I'll just give you a quick walkthrough of that. So whatever we are going to discuss is very well documented on MS Learn on this page. We may be covering, you can say, we will be discussing a lot. However, the structured step-by-step guide which you can follow, or if you want to reproduce what we are going to talk about, all of that will be on that page. So if I take you to this, you can simply sign in from the top, and you can save your progress as well if you do that. Now sorry, check this out. So it is basically having various modules over there. Now, we'll discuss all this. We just want to show you, or let's have a look at this, right? So the thing which we were just discussing, that the AI or the impact of AI on our life, right, is it's pretty deep rooted as such. So whenever you talk about any approval in insurance, or approval of any financial service or any loan approval, then the decision by which either you got the loan or you just got disapproved over there, that decision has been taken by one machine learning model which has screened you out, or maybe you got filtered out, or maybe you got selected, and then you went for the next evaluation round over there. So the acceptance into any school, college, and so on and so forth, as such, the screening of the the applicants over there. Now, these things can be very harmful as well. Like, can you just practically think through the because of any bias, or if the AI system decide to you can say extend, or maybe withhold the opportunities, or the resources, or the information for certain group. If the AI system does that, like it suppresses one of the group, or it gives more opportunity to another group, right? In any field or domain, that is something which is having going to have a huge impact. So, uh, apart from this, like the harm of allocation is one of the common type of harm which AI, you can say, unresponsible AI solutions can do. Second thing is that they can also do the quality of service can be harmed as well. Let's say the AI system which you have created, maybe it's a voice recognition system. It is working very well for maybe one type of, let's say for women, but it doesn't work well for men, or vice versa. Or it works well for people having some particular type of accent, but doesn't work for the other side of the world, right? This is something which we categorize under the harm of quality of service as such. So there are two things which we would like to understand. First thing is that harm of allocation, and harm of quality of service. Harm of allocation will be either you give more opportunities, or you suppress some certain group because of some XYZ reason, which we will also understand on the way what they can be. And the second thing is harm of service of quality. Now, so all of those things are basically on this module as well. So if I just zoom out over here and just show you a couple of important things which I just want to cover first. Now, it is very important for us to understand that what is the meaning of fairness. Like, if I am saying that the AI system is giving somebody more opportunity, or if it is not giving opportunities to one section of the population. Population is the practical population, like the you have your subset of the population, and so on and so forth, or think in any context as such. So then, what do you mean by fairness? Like, when it will be fair as such? Like, for example, there is a very nice thought process which has been done, one thought experiment which has been done, which we will understand over here, and then based on that, we will further try to understand more scenarios. Now, uh, so there is one example we'll take right over here. Let's take an example. Now, so the example which we are taking is of a classification model, which is going to predict the probability of the successful loan repayment. So the loan repayment probability is being calculated, or is being predicted by the classification model. It's going to classify like in some category 0, 1, like that. So now this is going to impact whether the loan is being approved or not in the first place. So there can be few of the attributes can be like that. You can think of that age is one of the attribute. If you think about loan getting approved or not, age can be one of the factor. The people who are younger may not be getting the loan approved because they may have just started their career, and they may not have the resources to, they may not be so well settled, and they may not be able to you can say uh, pay back the loan amount over there. Employment status, whether you're employed or not. Income status also, whether how much income do you have, or do you incur as such, of your saving, and any existing debt which you have. So that also makes a difference. Or these can be, you can say, few of the attributes on which the loan approval may be done, right? These are now, so we will take one example and we'll understand, is it fair or not? So now, Okay, so imagine this is the population and where the machine learning model has already screened few of the people out. So loan approved, approved for this person, for that, for this, for that, and so on and so forth. For others, the loan is not approved, like that, right? So now the next thing which comes to your mind is like, is my model being biased towards one gender, or is my model being biased towards one sensitive feature? Sensitive feature can be something like age, or maybe gender, or race, or maybe some sort of you can say maybe towards few maybe a country, a location wise, some sort of disparity might be there. So if you want to understand whether it is that the model which you have, if it is biased or not, then what is your thought process, right? So what we see over here is that suppose the model predicts that around 45% of the applicants will successfully repay their loans. However, on on further investigation, you begin to suspect that few of the loans are approved for applicants below aged. You can say fewer loans are being approved for the applicants below 25 years of age or younger, and more loans are being approved for the people who are more than 25 years as such. So you were suspecting that, like, okay, something is going wrong. So what you did, you basically divided your population into two different subsets over here. Now you picked up the age as the sensitive feature. Sensitive feature is the one which by which we are trying to understand whether the model is doing a fair behavior or not. Now, this sensitive feature may not be the main feature by which we are going to find the this may not be the main attribute which is going to impact the label or the target attribute. This may be something which may be there impacting some other features which you have, and they may be finally going and impacting the target attribute. So there is nothing like this is the most important feature and so on and so forth. That's not the primary idea over there. But now, so what we did, we divided the population into two categories. We have the subset of the population here who are equal to 25 years age or smaller, and here we have the ones which are bigger, and we are doing a selection rate. Selection rate in a binary classification problem statement means the how many positive predictions happened. So positive prediction right now, what we are considering as positive prediction is that your loan got approved. You got classified into the positive class. Your loan is approved now. So now to find the fairness, if you may do this, right? If you do that, I'll just show you what mistake we have done. Right? If we do something like this, we using one sensitive feature, we divided the population into subsets, and then we finally found the ratio between the positive rate. So now, uh, sorry, let me just properly zoom into this page. Okay, so now you found that the model predicts 36% of the applicants aged 25 or younger will repay a loan, right? But the prediction for the successful payment of is 54 for the applicants which are over 25. So there is a disparity of 18%. So just by looking at these numbers, it looks like that the model is unfair to the people who are younger. It seems looks like that. Like there is a 18% disparity. Like only 36% of the younger population is getting the loan approved, and the model is suppressing them, and the AI solution is favoring the population which is beyond or having age beyond 25. But that's not the correct assumption over there, because practically, if you think it through, uh, and we were just discussing 2 minutes back that, right? That when we talk about loan, it also depends upon that the person who is very well settled will be, let's say, a person who is, if you are comparing someone who is having 44 years of age versus someone who is right now at 22, right? So the when you talk about the bank balance, or when you talk about the like how well settled the older individual will be versus the younger individual. So because of that age difference, obviously, or by using common sense also, we'll come to understand that it is possible that because of this reason, the data set is imbalanced in the first place itself, and we have more And the subset on which we are training the model is not the correct representation of the population, and it is basically more you can say it is a bias towards, it's not really bias, that's how that's how that particular scenario is. So just by just by dividing the data based on some sensitive feature and calculating that, like the classification will not be the correct approach. So the correct approach which we have to take in this scenario is something like this. So instead of doing that, we will be measuring the disparity between the predictions performance. For example, if we think about classification model, we know that there are various evaluation matrices such as accuracy is there, precision is there, recall is there. Now we are going to further proceed with the help of recall. What is recall? If something is already, let's say, in if you really think it through in any natural language, recall versus precision. Precision is something like if you are telling me something, how many times are you correct? That's precision. Recall is when something is already correct, how many times have you told me? That's how many times did you recalled it. So now recall is something which we are going to take for both the categories of data set, like the people who are less equal to or less than 25 years in age versus the people who are more than 25 years in age. And with the help of recall, we will try to understand that is there any disparity or difference between the recall prediction, uh, the the recall which has been calculated for both the the groups. So what we do that. Now we realize that, so imagine this is also, we are supposing it, I'll show you how practically we do it, but now have a look at this. So what we notice is that the suppose the loan approval model exhibit that the overall recall is 0.67, so 60% of the cases where the applicant repaid the loan. So what value will the recall factor capture over here? So from all the people who correctly repaid the loan or who did repay the loan, 67% were correctly identified by my model, rest were misclassified. So keeping this in mind, when we will apply recall for the two age groups which we have created over here. So hypothetically, let's say that the recall for the validation cases where the applicant is 25 or younger is 0.50, and for the applicant which are over 25 is 0.83, meaning that your model which you created for the loan approval, when it was doing the prediction for the younger population subset over there, then 50% of the time it was correctly identifying that so let's say 100 people did the 100 people who are lesser, you can say younger than 25 or equal to 25 years in age, 100 of them did the loan repayment. They did historically did paid it, but your model only found or was only classifying 50% of them correctly. 50% of the time it got misclassified. But versus when you were doing it for the when your model was doing it for the age group which is more than 25, 83% of the time it was correctly classifying them, and the rest of the time it was doing a wrong classification. So now here 50% are getting misclassified, only 50% are getting correctly classified, and the 83% is getting correctly classified, rest is getting misclassified, 17. There is a big disparity between the prediction or the ability of the machine learning model to correctly predict whether the loan will be paid by the age groups or not. There is a big disparity over there. So the disparity over here in this example is around 33% over there. This model is really not doing a very good, uh, you can say, job as such. So this is the approach which we will be taking for the purpose of finding the fairness or unfairness. We will not be just taking the positive selection rate, like, okay, let's say there are three age groups, or there is, let's say, two, we have gender. So let's say in gender groups, maybe the person got is got classified into one class versus other. So just by instead of just selecting the selection rate, like, okay, how many people got the loan, not got the loan, and so on and so forth, we will find that maybe we will pick up one of the metric like recall, and we'll try to understand that, okay, is there a is there a disparity between the prediction power, or in my model predicting the classes when they really repaid the loan, but my model did 50% of the time misclassification. There can be a lot of justification for this, right? We are not saying that there can be a lot of justification. For example, data, when you got the data, it was anyways imbalanced in the first place itself. That's totally can happen, right? Secondly, the correlation was not fine. This is very interesting. Now, indirect correlation was there. So have a look at this. Let's think about the credit history. So we'll take the same example. So we have two groups: the group which is younger than 25, and the group which is older than 25. As such, same two groups, and equal to. That smaller one is equal to as well. So now the group, the person who's having 44 years of age, because of that 44 years that person was on the planet Earth, the he or she might be having a bigger credit history. The person may have applied for loan many times, may have gotten approved many times before, may have defaulted many times before, or may have paid it more times before. So if you do not have something, so but the person who's younger, because he never got the opportunity, he just sort of is just of 21 years age or 24 years of age, or maybe less than that even. So that person don't have that big credit history. They didn't apply for the loan earlier, they never got it before, like last time, or maybe before it, and so on and so forth. They don't have the history over there. So your model, so when you trained your model, it didn't had this attribute, credit history. So credit history was very important. So what will happen if we don't have some important attribute like this? If we don't have it, then these sensitive attributes such as age, the machine learning models, they will just think that age is the one because of which it always, like the people who have have more age are will do the loan repayment more. It may be the soft understanding over there. But if we have the credit history, the correlation will be that, okay, it's the age, but not only the age, because the credit history is also big, because the age is more. Now we take that factor also into consideration when we deny somebody or when we approve the loan for somebody. So you will do less misclassification for the older ages as well, and for the younger ages as well. Now, so find the features. Now, okay, so when we talk about data imbalance, take care of it. We have oversampling can be done, undersampling can be done. We can also create synthetic features as well. uh, Spend enough time in the feature feature engineering, in understanding your data, in understanding the various attributes which are there. There can be social biases as well, like the data was collected in some particular way, it was prepared model which got influenced because of some particular uh, location, age, race, and so on and so forth. So that is also there. So what do we do? Like, okay, there are so many problems. Now, how do we take care of these so many problems, right? So this is where we will be able to use the libraries which we have. So let's go through them. Okay, I'll just skip a couple of the slides which I have over here because we already were discussing that. So there is no second thought in how important AI is today, right? It is in every single factor in all the different decision making. It plays a big role. Okay, so what is fairness? We understood that. What is the meaning of fairness? It's just not that. A lot of time it's just not that evident. We have to go for the disparity between the different metric which is there versus just the selection rate. So before I go into more depth, I just want you to go through this page, or we'll just go through this page together. Now, responsible AI is something which is pretty important, right? Because right now, the AI solutions which we create are not really centrally regulated. Maybe in some part of the world, or maybe in some of the scenarios, but it's something which is like a wild west right now, uh, and various people can use it for positive and negative approaches or use cases as well. So as part of the responsible AI, we have fairness. That's what we are going to discuss today. How can we make things fair or not? So biases can affect the result, like loan approval example, which we just took, right? Maybe which with the help of the gender also. The reliability and safety. The errors may cause harm. The autonomous vehicle crashed and killed somebody is something which should not happen, right? Privacy and security. Data should could not be exposed. So if you are training the machine learning model, if I give you my data and you are the ML operator, so you may be getting the access of my data. You will be able to look at my data. So that is a potential. It's the potential source of the leakage as such, or from where the data can be exposed, the private data can be exposed. So I'll tell you some approaches today by which we will take care of it, right? So the medical diagnostic bot is trained using sensitive patient data, which is stored insecurely, right? This part. Okay, the solution may not work for everyone. So you made one application but provides no audio output for the visually impaired user. So you just left them out. Transparency. The user system should be maybe very complicated, but uh, we should be able to, you can say, explain it. Model explainability is absolutely required to understand. First we will understand whether the model is fair or not. We will understand the model which is fair or not by understanding our the explainability of our models. Accountability. Who is accountable for, we can say, if something goes wrong, then who's accountable for that? Now this part we were already looking at. I'll take you to the interesting parts over there. This is the thought process which we just talked about. Now let me just take you to my whiteboard, and I just want to show you the life cycle of the responsible AI. How does it look like, and what are the various factors over there, or the various things which we should be uh, considering in this. So if I just show you this responsible AI principles, right? It is basically built on three major principles: understand, protect, and control. Now, when you understand, right? So the model which you are creating should be explained. You should understand it. Like if the model did a type of prediction, why did it do that? What was the reason behind it? Which feature is the locally most important feature because of which this output came? Or what is the overall most important global feature importance, or which is the most important global feature because of that particular output came? Now, this particular one point over here, the interpretability of the model. I just want to show you something. I will just go back to my slide deck and open the slide which I would like you to have a look at. So we have libraries available. These are open source libraries, but these are available in Azure as well, obviously, and in other, you can, so open source, you can use them anywhere. So the global and local feature importance are one of the outputs of the explainability, or the when we explain the models, then these two things are created. Global feature importance means that overall, which is the most important feature? Like, okay, income may be the most important feature, right? Overall, in that data set. The local feature importance means that, so this is overall, like out of the entire data set, which attribute is most important. See, but because of that, the income might be the most important attribute overall in the data set. But when the person came, when this one the application came, right, and when your AI model either approved it or didn't approve it, right, for this one particular observation, for this one particular applicant or application, and so on and so forth, which feature was the one because of that the prediction, or what were the few features because of that the prediction was of one class or of zero class as such. So local feature importance is, you can say, observation by observation. Let's say if five applicants are there, five rows are there for prediction purpose, for scoring, then in those five individual instances, which feature was the one which was, you can say, more important or most important as such. So global and local feature importance are two things by which we will be able to explain why our model is behaving in a particular way. which is over here, the first one. Now, the second one, which we will be spending more time into, the fairness. I'll show you the libraries we have to use. So before we go in that second one, we'll just have a look at the protection over here. The third one, now differential privacy and confidential machine learning. So this is what we were discussing a few minutes back, that if you want to train maybe a convolutional neural network to do a prediction on the patient X-ray images and so on and so forth. And if you are the data scientist or you are the machine learning the engineer who's developing it, or we'll just call them maybe, let's say, ML operators, or maybe you are the AI operators who are, where you are developing it, or you are handling the data. So because of the need of that data to train the model, we need the data to train that model, right? But that data might be very sensitive, because it's part of healthcare data. We may have more sensitive data in other domains as well. So how do you ensure that we are able to train the model accurately accurately, but still the security or the secrecy or the privacy is not breached? How do we do that, right? So there is a particular library called as smart noise. Remember that, right? Smart noise. So Microsoft also uses, we also use that heavily in Azure machine learning. It's open source as well. So what smart noise does, it add noise. It add some noise to the data. So data statistically remains same, but it's not exactly what it was. Like the relation, the correlation between the attributes, they remain same, right? Or similar. It's, if you add a lot of noise, they will, you can say the prediction will definitely get impacted. But when we control how much noise we are adding, we are able to fairly, you can say, train a very good model. But we also do not breach the privacy of the data owner itself. So smart noise will add noise. So that particular, uh, you can say, that particular step, feature, or working is what we have as part of differential privacy. And as part of Azure Machine Learning Service, this is something which we do. Now, the other one, the confidential machine learning. Now, this is something which I want you to have a look at. I didn't make that picture. I just took it from the internet. So whoever made it is the fair owner of it. Now, uh, so we have there is a particular from Microsoft Research, one library is created or open source now called as Microsoft Seal. What it does is to train the machine learning model, right? It doesn't need decrypted data anymore. So data will remain encrypted. Still, the computation will happen on top of it, and the output will also be encrypted. So it never gets decrypted. The training happens itself on the encrypted data itself. So this is Microsoft Seal. Use it's available on GitHub. I will see if I can just put uh, the link of that page in the chat window. Okay, so I got the smart noise, and I'm putting that in the chat. You can bookmark it. That's smart noise over there. You can read more about it. That's for the differential privacy. And the one which I am going to put now is Microsoft Seal, which is in the chat. I can see there is a hand. If you can put the question in the chat, I'll take it on the way. Otherwise, I'll just we'll take the questions in some time, right? Okay, so the seal is also there in the chat. See if we can use that in our future projects. Okay, now check this out. The third part is the control and the audit as part of the responsible AI. So like as part of the documentation of the AI model, we have to save a lot of information, or useful things, or you can say that there is a checklist which we can save. So I will just show you a couple of information that you should be you want to document as part of your data sheet. So what was the intended use of the model? Model's architecture, definitely. The training data set which was used, evaluation data set which was used, training model performance metric, and fairness information. So minimum you should be having or saving this for your models as well. So I'll put this in the chat, and I'll give you the checklist as well. which is slightly bigger in size, or let me just put that in the chat now. It's there in the chat. Okay, so let's go back to the fairness over there, right? Now, uh, I will take you back to my slide in case I have another beautiful slide for you, but maybe I have skipped something in middle. And let me just go back. So data privacy problem, the differential privacy is what we were just discussing about, the smart noise part over there. And let me take you to Azure now, and I will show you the setup which I have for us over here. Okay, check this. So basically, I this is my Azure portal, and I have created one machine learning workspace, which is the primary machine learning service in Azure for custom AI purpose. And then I have simply launched it. So this is the interface, how it looks like when you launch it. So I will just quickly show you in case you have not used it before. So it looks like that. This is the primary ML service interface, Azure Machine Learning Service. Right. Now we have various things here. We are using that notebooks over there, which are like Jupyter notebooks. These type of things we have covered in the previous sessions. You can go for AutoML. We have covered everything in way more depth in the last 27 sessions, which we have done around 26, 27. More than half of them were on these. So I simply have created one compute instance. This is my development environment here. And I also have a compute cluster, which is the training cluster, which over here like this. These are Kubernetes clusters, or this can be like Databricks or Synapse Spark clusters over there to work with. Or attached compute can also be Kubernetes if you want to train the models on Kubernetes. Now, if I come back to my notebooks, I have this notebook with me over here, which I'm using over here. So the whatever we have discussed, like we were discussing about like how that sensitive feature needs to be there, and then we have to compare the metric, you can say in the based on the sensitive feature, will based on the sensitive feature we'll create the subset of the data, and then with the help of the metric we'll find the disparity between the recall, or if we are doing regression algorithm, then we'll find the disparity between MAE and so on and so forth, right? So that is already available as a library, right? So the library which we use is called as Fairlearn Library, right? So that Fairlearn is the one. It is open source. You can find it anywhere, right? There is a fairness checklist over here, like what all things it checks for. Like we were just discussing few of them, right? There are all the things which it checks for, right? So this is the entire list of the checkpoints. It's taking some time to open because actually I think it will download. There is a PDF over there which I need to download here. So you can download the PDF from that page. It will take you to the white paper. The white paper where you have to spend some time into reading the white paper. It will be slightly bigger, but whenever you have time over the weekend and so on and so forth, you can go through the details of all the things which the Fairlearn library will be checking. And this is based on the research which Microsoft has done with other you can say major players. Okay, now a couple of things which I want to show you is that when we use the Fairlearn library, it gives us these dashboards over here. So when I train my model with it, or when I use it to find whether my model is doing it properly or not, it creates these dashboards. See over here. Let me see if that was a different one. Okay, let me see which one is this. I kept the old ones open. Okay, so this is the dashboard for my particular use case in this point in time. The data which I'm using is a diabetic data set, PIMA diabetic data set. It's a simple diabetic based classifier. We want to see see there are two things. First, you should know your model is unfair, and then how to mitigate it. The mitigation should also be there. How to correct it, right? So the Fairlearn library gives a very UI friendly way of understanding what is going on. So This is one of the sensitive feature which I have selected over there. Now, how do you find the sensitive feature also, right? This is not the feature which is always the one on which the predictor is there. The one of the but This sensitive feature can be the one of the features which is the which based on the global feature importance or based on the local feature importance, based on the model interpretability which we were just discussing about maybe 10 minutes back. Based on that, you have selected over there. It can be one or more. Right now it is, I have one feature. So now what do I want to do? Which metric is based on which I want to measure the performance of the of my AI model? Is it doing it well or not? So accuracy, F1 score, precision, recall, like that, right? What do you want to go for? Then how do you want to measure the fairness? Like how do you do it? So based on some accuracy, based on the demographic parity difference, the maximum difference in the selection rate, that is the fraction with the predicted label over there. Or do you want to find the equalized odds over there? Let me just explain what are these. What are these? I will just show you the. I'll take you to the documentation, and I just want to show you in my secondary screen. I'm just scrolling right now very fast, trying to find the correct page, and I think this is the one. Okay, now please bookmark this page as well, right? This is going in the chat. Now, so let's have a look at this. So what are the various attributes of what are the various terms or terminologies which we are using there? The demographic parity, so it mitigates the allocation harm, right? There were two type of harms which we were thinking of: allocation harm and the harm because of the denial of good service. So either, let's say, one part of the population didn't got uh, the opportunity was not given to them, right? So allocation harm. And bad quality service is like you sort of, your model is not behaving well, your voice classification or your voice enabled AI assistant is not working for uh, male or female. It works well for male or female, or it works well for some particular uh, accent or language, and so on and so forth. Okay, now, so those are the quality of harms over here. So basically we have the equalize, we have like the parity constraint, the equality constraint. Like there are different type of constraint the Fairlearn library will put on your ML model. So those constraints it will put on the AI model are, you can say, are of few types over here, like that. So like equalized odds. So diagnose the does the diagnostics on the allocation and the quality of service harm. Equal opportunity, like equal opportunity was given to all the various sensitive feature based subsets or not, or there is some sort of bounded group loss, some sort of loss is happening in so and so forth in part of it. Now, okay, we have mitigation algorithms as such. Like when you find something is not working, then you also have to mitigate it. You should have some way to do it, right? There are two ways. One is a reduction operation. Like we have algorithms which will do the reduction as such, and the second are called as post processing algorithms over there. So if I slightly zoom out, so you can also properly read the entire page over there. Take your time. The link is in the chat. It will take you some time to go through it. But here, what happens in the first one, the reduction uh, the reduction algorithms for the mitigation of the unfairness will retrain new models. The new models which will be retrained will be having multiple models will be retrained, like just FYI. So the multiple models which will be retrained, we will okay. So let's say 5 models got retrained, right? Now in the 5 models, different trade-offs were there. Like, see, if you're trying to make it more accurate, there is a trade-off. You have to give more weight to few of the, let's say, to one gender, you have to weight it up or weight it down. Why will that be done? So that final output is not unfair. It is fair to both the genders, or to all the genders, or to all the subset of the ages, or so on and so forth. So some of the uh, you can say attributes will be weighted up, some of the classes will be weighted up, some of them will be weighted down as such. So multiple models will get trained. Now because of that, there can be a difference, or there will be a difference in the accuracy. So we will be sitting and seeing that, okay, based on the business rules and the cost of the calculation, which one is okay for me? How much, what is my tolerance level? How much of inaccuracy, or you can say less accurate solution can I provide, but it is fair? So just to give you a line of thought, uh, if your model is not fair, right, but it is 99% accurate, that is not good, versus a model which is just, let's say, 95% accurate, but it is fair to all the gender and all the age group and so on and so forth. So that type of call is something which needs to be taken. There is no rule of thumb. There is nothing like, okay, how much do you think is the fair or unfair? That rule of thumb is not there. Now, the second thing is post-processing algorithms. These are interesting ones. Now, the good thing about these are that they do not train another model. Here, new models are not trained. It is the same existing classifier which we have trained, right? On the same existing classifier, it will sort of, you can say, enforce the fairness constraint on top of the existing model, on the existing classifier over there. So it doesn't retrain a new model. So there are two different categories of algorithms as such which are available. Sorry, which are available. Now, okay, so you can definitely go and read about the algorithms further over there. I'll take you back to the dashboard which we had over there. So now if you can see, we have all of these like equalized odds based on F1 score, precision, recall, and so on and so forth. Okay, so if I click on something, let's say over here, either the maximum difference between the true positive rate of the two of the groups and so on and so forth, I just want to show you the next page. I'll zoom out slightly, right? Okay, so now, okay, so it will provide us a type of graph like that, which is easy to understand and explain to others also, like why we are doing this. And this is the you can say the fairness. You can say the metric which will be created, or this is one of the table which gets created. So you can see that overall, what was the recall value, what was the selection rate, the I'll just zoom out slightly more. So the equality of the odds for the predictions and so on and so forth. It gives me the entire idea, and then it gives me more options here, and then more options over here where I can understand, okay, 50, this is a PIMA diabetic, so 50 years, it went 50 and younger, right? So like selection rate of being classified diabetic is more for more than 50 in women of more than 50 years, and then this is younger, like that. So now this is that fairness dashboard. Now there is one more thing which I want to show you is when we do the mitigation of it, right? Then there is another dashboard which gets created, and let me see if I have kept it open for you or not. And I think this is the last one over here, like this. Otherwise, I'll just walk you through the code itself. And let me zoom. Okay, it's already zoomed out. So let me just refresh the page once. Okay. Okay, this is actually, these are the various models which I created. So let me show you, let me take you back. So as we were discussing that the reduction algorithms are there, they will create multiple different models as such. See, so we have so many more models which were create mitigated models, 1, 2, 3, 4, 5, 6. We can specify how many we want, but basically these are the models where different constraints were applied, or different weight of the constraint was applied, and based on that we are getting one output where we have to sit and decide that, okay, like the parity difference versus the accuracy. So is accuracy going up, or is it going down, or what is the ratio? So when few of the sensitive features like age, or maybe let's say your in the PIMA diabetic, we can say here also we have taken age only, but any other sensitive feature based on which we want to understand whether our model is fair or not fair. Based on that, it is giving us the understanding of that if something is weighted up or weighted down, what is the impact of that on the accuracy? Because that might be a business loss to me as well. Not in this healthcare scenario, but in any other scenario, if you practically think it through, it will we have to calculate the business cost as well. So here you see that all the models which are there, they have different values of accuracy versus the how much of the parity difference is there. So parity difference is increasing. The difference is increasing here. The difference is decreasing. So it's doing a better, you can say, recall value for the subset which is less than 25 years age versus the more than 25 years age is less. So difference is reducing versus it is increasing. And what's the impact on the accuracy? So you see this subset over here where we have the most accurate but the least difference is there in the as part of the sensitive feature difference over there. This is something which we can think. See, there is one more. It is 90% accurate, and it is slightly more. It is having slight more difference than that one. See over here, it's even better accurate. We can even you can say go for these. Now that is a call which you need to take. Like, okay, if you see, these are the ones which are you can say sorry, these are the ones which are less accurate, 83% accuracy, and but the difference between the parities are also, the parity difference is also less over here. This is even less, but the accuracy also comes down. So Fairlearn library is not the magical library which will do it for you, but it is one of the library which will be or one of the thing by which you will come to know that your model is not performing well. You can take corrective measures. It will not be the only one as such. You may have to think of for your particular domains of more scenarios or more things can be done. But this is the life cycle of responsible AI. Please do think about the explanation of the models. Models should be fair as well. How do we find the fairness with Fairlearn? And what are the concepts over there? Differential privacy will be smart noise. The confidential machine learning is something very, you can say, game changing as such. The ML can be done on the encrypted data itself. No need to decrypt the data over there. And then what are the document from the documentation's point of view? What are the things which we need to document? All the list as such, right? So this is what we designed, or this is what we had for the session, and whatever we have discussed, right? Whatever that the ML model which uh, I was using over there. If you want to reproduce whatever we have done, you can go to that page. And what I have done is on the module number, I have to zoom out here, and is over here, this one. You click on this exercise over here, and you click on that link, and on that link your the Jupyter notebook will be there, or the instructions will be there how to find the Jupyter notebook, or how to load it, import it, git clone it, and so on and so forth, right? On this one. So this is where the entire uh, uh, session is available on that one, right? So you will be able to uh, reproduce that. Okay, now I'll just go through the questions. I will see if the what are the various questions and so on and so forth. And if somebody wants to unmute and ask the question, then also please do that. Okay, I'm just scrolling back up in the chat window, and yeah, the previous sessions are on YouTube. I think the link on the YouTube is also there as well. All the sessions are amazing. You can find my sessions and other sessions also if you're interested in any ML on Spark, Kubernetes, and so on and so forth. Uh, we do a slight, as you can say, the less popular ones. We do the ones which are, you can say, little more cutting edge, and maybe in few years they will become more popular. So those type of sessions will be there. So go and check out few of them. Okay, so then there is no other question. So if there is anybody who wants to ask any question, please go ahead and do that.
Great. So while we are waiting for questions to come, Please feel free to share your feedback about today's session. And also, please use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. And yeah, I mean, the survey link is there on the screen with the event ID. So you need to put the event ID and please share your feedback. It's very important because it helps us to choose our topics for future sessions. So please, and also important the learn module. So whatever Shivam said for today's session, you can just go and do it yourself. You can learn for your own purpose as well. And also you can reach out to Shivam. His LinkedIn and all his social handles are there on the meetup page. If you have any questions regarding today's session or learn module, you're always welcome to reach out to him. And if we don't have any questions, so we can wrap up the session for today. So thank you, Shivam, so much for the session, and thank you all for joining us today. And enjoy the rest of your day. Thank you.
Thank you. Thanks, everyone. Have a nice day. Thank you, Rashmita. Thank you, Parth.
Thanks, Shivam.